I'd like to talk about the river morphology information system, especially on the cyber infrastructure side. So my name is Ibrahim Demir. I'm an assistant professor at the University of Iowa and the director of the Hydroinformatics Lab. And on the Iowa side, we have with me also the Marian Masti, the COPI, as well as the researcher, postdoctoral researcher Yusuf Sermet, working on the infrastructure for the river morphology information system. Definitely with the support and help with, and contributions from all team members on the project. So I'd like to talk about the high-level overview of the system, and starting with the cyber infrastructure, the architecture, the backend, front-end, as well as the referencing system, the data resources API, and data exploration features. And we will also have a live demonstration of the system by Yusuf, going over some of the capabilities and features that we already designed, but also there's many more coming, hopefully, in the coming year. So I'd like to start with the website. So everything about the project you can find on our website, project website, RIMORPHIS.org. You can access all the past workshops and presentations, videos, and we also have publications and presentations will be available on the resources section as well. You can access also information about being a data partner as well as a beta user, a pilot user for the system in the coming session. So our goal here is to have a community of users, but also data providers and providers for new tools and analytics capabilities for the system. We like to connect with the community to add more capabilities and features to the system as we work with you, with agencies, organizations, and institutes. And on the infrastructure side, here's just a high-level architecture of the system. We have our landing website for the project, but also on the background, we have the backend environment for the platform, as well as a front-end system for the information system, which is mostly dependent on the PostgreSQL database system, a PostGIS environment for processing geospatial data. And also we are using an API to serve all the data to the backend and to the front end. Also, we have another API endpoint for the end users, which we are going to talk more about that as well. On the backend side, we are mostly utilizing Node.js as the main engine, but also we are utilizing Python for some of the processing tasks. On the front end, we are utilizing mostly JavaScript, HTML, and CSS as usually as a web application, but we are also utilizing some high-end web libraries, WebGL and GPU processing for some of the 3D visualizations and some of the data analytics as well. And on the referencing side, so before we collect any data, before we integrate any data sets to the system, we want to bring in a referencing system for locating all these data surveys, as well as products that we would like to publish in the system. So we started with NHT plus HR, the high resolution, to define a referencing system to connect all the objects, all the data sets, all the surveys to the NHT, so we can easily locate, we can easily track any object, any data and survey in the system, starting at the HAC4 level, going all the way to HAC12, and even further. You can easily locate any object within that kind of referencing environment. And we also connected to flow lines and junctions from NHT as well. In terms of the details, we are using most of the NHT IDs and definitions, but also we have our own internal IDs and references to have a better connection, and also for long-term sustainability and to handle any changes on the NHT side, as well as any changes, any updates on our side. We are definitely connecting that two pieces together with multiple referencing and multiple relational environments. And on the referencing system, here are the high-level objects defining from catchments to the flow lines and junctions. We have all these objects in the NHT connected with NHT plus IDs, but also it has the reach codes, internal IDs, as well as all the geometries and all the metadata is connected to the database, PostgreSQL database, which helps us to identify every data survey within the NHT environment, which helps us to visually search and also browse these data sets, as well as categorically search and find the relevant data for a specific location easily in the system. And just by looking at some of the early data collection efforts, we are focusing on the Upper Mississippi as well as Ohio as a prototype, hopefully potentially extending and scaling up to the entire US. with the second phase of the project with geoinformatics funded. And currently, the current numbers shows that just by dealing with these two watershed on the Upper Mississippi as well as Ohio, we are dealing with 1 to 3 million catchments, as well as 600 to 2 million flow lines, and similarly 600,000 to 2 million junctions. And these are all well connected and related to each other. And every data, that point that you want to access and search and find, will be connected through this hierarchical referencing structure. And on the API and data resources, we define our own custom data model just to be more efficient and also have only the relevant information that's required by the platform, by the system, and which will serve an efficient data, provide an efficient data model without any overhead, without any extra metadata that's not required for the operation of the system. And it's well defined and connected with the NHT. So starting from any HAC level, from HAC 4 to HAC all the way to HAC 12, connecting back to the catchments and flow lines and cross-section surveys, and will potentially include some observational data as well on sedimentation, roughness, and other survey data will be connected to the system. We are extending the data model as we access to new data resources as new data surveys from different organizations, agencies. Also, we are planning to open up to some of the user level data integrations and uploads as well for most of these kind of long tail individual data efforts. And you can see some of the high level data model here on the side, on the right side, with all the catchment related data, flow lines, cross sections, even the organizations and surveys and contacts, and all the information will be captured in this data model, which helps us to identify the data sources, the contacts, and the institutes, and all the relevant referencing system will be available in the environment. And this will help us to connect with external data sources easily. So one example we have integrated is eHydro. Our goal is not to replicate these big data sources on our system and create more redundancy and extra maybe efforts. So our goal here is to integrate, if possible, and in an efficient way, directly to these systems without downloading, without replicating data on our servers. The goal here is to access the eHydro and similar systems on demand instantly as the user interacts with the system. We might potentially keep some of the high-level metadata to make the search and filtering faster, but the goal here is to access these eHydro resources on the fly, transfer to the system on the client side without any server-side potential processing, and then utilize this data for visualization, and then maybe some server-side or client-side processing for the creating mesh from points or cross sections or other geomorphologic units of features. And here you can see we have already integrated eHydro for the selected regions, which you can see normally all the surveys you can download. As the Venkatesh presented, you had to download this the database and have to process in GIS environment and do lots of the things manually. The goal here is to minimize this effort, have an instant integration with eHydro, and demonstrate the analytics and visualization capabilities instantly. So we'll have a live demo in a couple of minutes. So I'm just going to go over this a few more slides. On the API side, the API is mostly designed for serving the platform itself, especially for the referencing as well as some high-level data features. But for some external data sets that we are collecting from small surveys and some of the data set that's not available outside, we will potentially open up this API to external users, external systems. So you'll be able to consume this API in your own environment, in your own models, analysis, as well as systems. But most of the capabilities will be initially designed for the platform itself to be more efficient for serving, analyzing, filtering, and accessing these data resources. It's a modern API with all the get and set features. You can access and change certain things as needed. And we have all the endpoints defined with the detailed and interactive user interfaces, which will potentially make it easy for people to also users to access and download this data as well without potentially requiring to use an interface. You can use the API for some data access or some automated processing on your side. So I'm going to stop here and I'm going to give the floor to Yusuf. So he's going to present a couple of more slides, just high-level slides on the design, but also he will make us a nice demo.
Right. Hello. Yeah, good afternoon. So are you all seeing my screen?
Yes, Yusuf.
Okay. Perfect. So just a quick second, I'm having a quick glitch. My apologies. All right. Sorry about that. Okay, assuming that you are seeing my screen again. Right, so I'm going to briefly talk about some of the features we have in the platform with screenshots, but I'll keep it brief and we'll move on to the demo. So regarding data exploration and visualization, we have adopted a visual browsing approach and eliminated the hassle of going through forms and whatnot. So the user starts from a higher perspective with the HUG4s and then zoom in and interact with the map and go into HUG8s and then HUG12s. And after that, the context changes as the user zooms in and displays some of the NHD level flow lines and catchments. And after that, the context changes again to reflect some of the cross-section surveys we have. In terms of the user interface, the system provides two different, let's say, perspectives. One is 2D to display some of the contour lines and KMZs and markers in these kind of conventional data on the map so that user could see the raw data and what's available. In addition, we have a 3D view that we are utilizing 3.js and deck.gl to form different types of 3D views, and the example shown here is a 3D mesh formed from the points. Regarding data analytics, as of right now, as part of this demo, we have deployed the cross-section processing tool, which accepts raw cross-section surveys and to be processed to create a 3D mesh. And then if the user desires, ready to be downloaded to the user computer in the desired format. This is an example output of cross-section line, processed cross-section lines, reflecting the substrata in the riverbed. Another use case for the cross-section processing tool is the manual input. So in cases where users would like to provide their own surveys, their own data, either right now or from an historical record, they could just upload their own data and use RIMORPHIS as a means to visualize and process and download their own data conveniently. So this is an example result of the 3D mesh as well as the mesh points and the downloaded shape files, both in terms of the mesh as well as the intermediate files, if the user would like to continue processing on their own client. So moving on to the demo, if you give me a second, I will change the view real quickly here. All right, so I believe that you are seeing my screen right now. So this is the overview of the RIMORPHIS platform right now with the prominent features as part of the workshop. We start with 0701 catchment, as a demonstration. As the user zooms in, the context slowly changes and in a smooth manner. We are at the HUG8 level and the user can hover over them and see the associated metadata. Same goes to HUG12s as well. And at this stage, we are also getting the available eHydro surveys on demand and reflect them as clusters so that the user would know where to zoom in or where the data is available. I'm going to zoom more than the HUG12 level. And as you can see, as I zoom in more, the context changes again to reflect NHD level catchments and flow lines. And I can just hover over them, see the metadata, and as I hover over this flow line, you can see an information panel on the upper right. I will continue zooming in to a cross-section survey that's coming from eHydro near Raspberry Island. When I click on it, the data will be retrieved on that moment and reflected on the map as a KMZ file. So this is what you're seeing is the raw data that we retrieved from eHydro. And you can obviously see it on the map, and you can check out different depths on the contour lines. On the right, you're seeing the associated metadata for this particular cross-section, like the survey data, the survey date in terms of start and end. You have the URL here to download all the geometry files that eHydro provides, and some of the data like lat long and the projection. Now, what you can do on RIMORPHIS is to use this cross-section survey in our cross-section processing tool. What we will be doing here is to get all of the geometry files from the survey and get the overlapping flow lines from NHD for this particular boundary and process all them on the back end to produce a 3D mesh. As the output, you can select either the cross-section lines like I showed on the presentation, or you can directly select the mesh. So for this case, I will select the mesh. I'm not going to select in a download format because I just want to visualize it right now. So I'll keep it as not applicable. So when you click on Start Processing, it may take, depending on the size of the cross-section survey, how many points are there, how many flow lines are included on that boundary, the processing time may change, though we kept it on 180 seconds right now for really big cross-sections. So here, okay, now the tool has produced the result. You are seeing 3 different layers of output. The first one is the raw data, as we have just seen here on the contour lines. The second one are the mesh points as an output of the tool, and you can see a finer view of the points in terms of their SN coordinates and the, like depth values and whatnot. And you can interact with these. You can check out different points. However, if you want to get an intuitive idea of what that riverbed looks like at that survey time, I'm just going to disable the 2D view. I'm going to disable the raw survey results so that I have this clear picture, and I can interact with it. I can change the perspective and see how it looks like as an intuitive map. And you can zoom in, zoom out. I'm not sure how it's conveyed on Zoom, but it's I'm hoping that it's working and displaying pretty smoothly on your computers as well. So yeah, that's an example of the eHydro case for the cross-section processing tool. And I close the 3D view as well. And I can zoom out again, select other markers, like other surveys for processing. As you can see, as I zoom out, that context changes intuitively. Like I'm in the NHD level, again, going back to the HAC12 and the HAC8 and HAC4. Anywho, next step is that I will demonstrate the manual use case in case the user would like to provide their own data. On the panel, we have a menu. Currently, the toolbox includes geometry conversion tool, but I don't want to spoil the next presentation, but we have more tools coming up. So here, as an example, I will use a survey from Brazos River. I will choose the observations as a shapefile. I will choose the center line as a shapefile, and then the boundary layer again as a shapefile. So as output, I will keep it as a mesh, and this time I would like to download because the user would probably like to continue this maybe processing or analysis on their own computers. I'll choose shapefile as a download format. Start processing. Again, this might take a bit of time, but after that we will see the exact result. So on this use case, we are handling all the security measures and the workspace creation on the server as well as the transfer between the servers so that the user files are secured on a convenient and efficient manner. All right, so this is the result of the process cross-section. Obviously, this is more like a rural area, so I'm going to change the view to satellite. And as you can see, there's a bit of change in the survey coverage as well as the underlying satellite image. The reason for that may be that this survey was conducted almost 20 years ago. And this may be a great way to visualize how a riverbed can change, a long time, like on what manners for a certain reach. Again, I can zoom in despite the fact that we are displaying all these points and lines, with 3JS, and it's still working pretty smoothly, with the zooms and and pans and rotates, hopefully shows some of the optimizations that took place, on the back. So I'm gonna disable the process 2D layer to get rid of those mesh lines. If I want, I can always, make them come back and, check out what kind of values I have for a certain point. But for now, I will just disable that and check out the cross-section lines and the depth at certain locations. Anyway, without going too long on that, I will disable this and I will move on to the API real quickly. So as we talk about the presentation, as Ibrahim talked about the endpoint for the APIs, future users could utilize the system by a regular like endpoint-based queries by chaining the commands and filterings and queries and everything on top of each other. So that's there. In addition, we have this user interface for convenience and easy querying of the system. As an example, these are only the tables that we currently allow for discovery on the web. And you can see all the columns available and everything. But let's say that as the complexity increases, as we collect more data, it might not be intuitive for users to just check out everything. So we have the search functionality. Let's say that you're looking for anything related to cross-section. And you have the cross-section line and point, obviously. In addition, you have the roughness and sedimentation tables that are related to cross-section point. In addition, let's say the user would like to query any data with river name or associated with river. So they can say that, okay, what tables have river or river name as a column? And you can specify column, and you would get that these results that have a column with river name included. Okay, going to the data, here you can disable some of the ones, depending on your desired view. I'm going to give an example of a query. Let's say you would like to get the flow lines for Sauk River. This is pretty common, querying. I will just say Sauk, and I will add another rule saying that they only return the reaches that are longer than 2.5 kilometers. I'm not going to put any limit right now. There you go. So you can order these, manipulate them however you want. And if you'd like to download them, we are providing this easy interface to download in the format that you desire. As an example, I'm not going to enable batch download because this is such a small data. But if you'd like to get really sizable data, you can enable batch download and name the data, download or copy. So when I download it, I'm assuming that you are seeing my screen that this is an example JSON that's ready for visualization. Like I believe this is right now JSON. You can download this XML, as you can see. Sorry, I couldn't move. There we go. And obviously as a spreadsheet. So that's the summary of the API. And this is just to demonstrate some of the functionalities that's provided by the API, and it will be more useful as we collect more data regarding cross-section points and sedimentation and roughness and any other data types. So that's the summary. I'd love to have your questions, and thank you.